Okay. So, thank you everybody for coming. We have a very, very big room, very full room. So thank you very much for coming and choosing me over all the others. So thank you very much. So today we're going to be talking about operable software and more specifically about how we build that using TDD. And it's not necessarily the way you think. It might be, it might not, but for a lot of people and in my experience, it's not. So who am I? So my name is Martin Thwaites. I go by martin.net on the Twitters. Follow me for stuff about observability with a hint of British snark in there, so you've been warned. I'm first and foremost an observability advocate. So I have for many, many years been pushing the ideas around observability and observing systems, that kind of stuff. I'm also a developer advocate for a company called Honeycomb. We have a booth, come see us, blah, blah, blah. You all know the thing. Okay, so before we get onto the agenda, I want to talk a little bit about the motivations for doing this talk. So before I worked for Honeycomb, I spent many, many years consulting. And for the last 2 years, I've spent the time building a credit lending bank platform. It's not really relevant other than the fact that it needs to be very, very consistent. It needs to be up all the time. So completeness and things like that are really, really important. And what we found was the ways that people were writing tests, the way that people were building the software wasn't really building it in a way that you could run it in a bank. And we wanted to go full CD and all of that kind of stuff, which requires a few more things. So we built over the last 2 years a way of doing things that we believe is really, really good. And that's what I'm here to talk about today, which is the reason why I love talking about it, because I'm basically talking about what I've done for the last 2 years. So cool. So what we're going to do today, we're going to go through what I consider operable software. We're going to talk a little bit about how, as an industry, we test software right now. We're also going to talk about something called outside-in testing. And then we're going to talk about how does observability fit into this whole thing. Now, some of these terms will be things that you know. Some of them they won't. Some of them they'll be new. But hopefully, what I'm doing here is I'm going to bring together a load of concepts that exist in books and blogs and all of that kind of stuff and give you a practical way that you can use them to make your software better. Okay, so let's start by talking about operable software. What is it we mean by operable software, or what is it I mean by operable software more specifically? Now, for me, it's building for production. Too many times people build for their local development environment. They are fine, you know, we all know the term, it runs on my machine, that kind of stuff. We build for that environment of our local machine. Building operable software is software that's built to operate in production. So it's built to run on production servers. It's built to run in a production environment. And that's what we're building for. That's what we're catering for. We're not catering for a localized Docker container. We're building for that production environment. And that's our primary concern, because anything else isn't really what users want. It's also built with live operations in mind. So I'm talking about the ops team, whether that's you or somebody else, but you're building it so that that team knows what's happening. That team is actually running your software. The fact that it runs on your local machine is irrelevant. The fact that it runs on production is the most important thing. And that team, whether it's you or somebody else, are the people that are actually running it. It's also built for fast recovery. You may have heard MTTR. I know it's falling out of favor now, but the idea is we need to be able to recover our software fast. And that is what we should be doing when we're building it. We should be building it so that we think that this thing will be able to fail over, this thing will be able to recover quickly. And all of that leads to the idea that our application should be emitting some robust telemetry signals to tell us what's going on. And all of this is stuff that you should be doing day in, day out. And these are the things that I miss when I see engineers working with software is they don't see these things. They're quite content with hitting the big play button in Visual Studio, putting the debugger on, yes, it works, great, ship it, which is only part of building software. You build it for the production systems. You build it for users. Now, when we say software, what is it we mean? Because, well, we write code, we write applications, but that's only part of it. The software that you build is everything. It's your application. It's the tests that you write to prove that your application works. It's your CI/CD pipelines that allow you to do that in a centralized environment, that allow you to deploy this code to production. It's the infrastructure that hosts your platform. But it's also the tooling from your observability tooling. that allows you to know whether that system is running. All of that is the stuff that you build. That is your software. That is the boundaries of the thing that you're building. It's not the little application bit in the middle. Because if you build an application and you don't know that it's running, it is not running. So, let's talk a bit about testing, and more specifically about TDD. Because it is the new hotness, well, old hotness, medium hotness, some hotness in there somewhere. It's been around for many, many years. And it's often done very, very wrong, in my opinion. I'm going to prefix the entire talk with, this is my opinion, okay? So, what do I mean by TDD? Contract first. Now, when we talk about doing things TDD, we're talking about working out how something interacts with our system first. We're defining how something's going to interact. We're defining a behavior. We're then doing red, green, V-factor. Most important bit being the refactor, which everybody misses, but, you know, hey-ho. But we're also talking about test first and implementation. That's the most important thing when we talk about TDD. Now, the thing is, you'll notice there, I've not mentioned a class. I've not mentioned a method. I've not mentioned MOQ. That's TDD. Now, I'm not saying I knew up a class. I'm not saying that I inject all my dependencies using MOQ. That's TDD. However, TDD is often misunderstood as mock all the things. I don't know, I think my biggest class that I've seen somebody mock had 42 injections into the constructor. And they were writing tests around that. But they were writing TDD, because they write the test and then they do the implementation, but they inject all. Sorry, trauma. But it's also misconstrued as well as the idea of single method tests. I have a single method. I test that method. I inject some things and I make sure that my mock has been hit, because that's what we do with TDD. And it's really, really not. So if we talk about TDD and we talk about why is it good? Why do we want to do TDD? What's the reason why we should do TDD? Because if it's not got any benefits, then we should all stop doing it. But it does have benefits. So the biggest thing for me about TDD is it improves the design of our system, because we're writing a client that uses these methods. And if we can't use our methods, if they don't make sense to us when we're writing them, then sorry, they're wrong. If we have to pass in 15 parameters instead of passing in a complex object, probably not the right thing to do, because we're struggling to use it. And if you're struggling to use it, then other people are struggling to use it. So using TDD as a method to be able to write our code helps us enhance those contracts. It also improves our own understanding of our code base, because we're using it. We're using these classes. We haven't just wrote that class and then used a service to call that class. We're actually using it in various different ways. So we understand how that code should be interacting, what the outputs are. So our own understanding of our code base will increase. We also are documenting how our code works, because that's what your tests are doing. Your tests are using it. And if you've wrote them properly, then your documentation is actually in your code, in your tests. So you don't need to write comments. You don't need to write, God forbid, Confluence documents about all of your code. Do write a README, just to be clear. Put a README in your repo. It will help. So, why is TDD bad? So, the problem I see with TDD, and these aren't the reasons why TDD is bad, these are the reasons why the ways that a lot of people do TDD is bad. And it's not that it's bad, it's just a misappropriation of effort. They do potentially prove some things out, but that effort can be used in much, much better ways. Now the thing is, TDD is normally done in the absence of consumers. So you're doing TDD at your class down here, and you're the only user of it up here, and then your users are actually all the way up here, and they're using your APIs. But your class is solid, right? You know, you've got 4,000 unit tests on this class. and there are 12,000 classes in your application, but yours is solid. You've got 4,000 tests. With the absence of these consumers here, what you're doing is things in isolation, and you're potentially not doing the right things. You're not building the right things because you're concentrating on that class. The other thing is they can be brittle, which is one of the annoying things. The idea that you write lots of unit tests and then you do some refactoring and then you have to refactor all of your tests, that means you've not really got tests. Because I was talking to somebody recently who their entire way of doing this was if they had to do some refactoring, they delete all the tests and rewrite the tests. Trauma. So, that idea of making these tests so close to those classes means that you can't refactor. I would hazard a guess that a large proportion of the room shies away from doing refactoring on a large scale because of the amount of tests it would mean that they need to refactor. And they don't really know what those tests do. And if you are in the here going, that isn't me, you are lying. Okay. So let's talk a little bit about component testing. Now, everybody's, I'm assuming, seen this. So component testing is a subset of integration testing. Integration testing being a really abstract term that doesn't really mean a lot of things anymore. It can mean 20 different things to 20 different people. So what do we mean by component tests, or what do I mean by component tests? Now, when I talk about component tests, I'm referring to the idea of outside in. These are tests that we write from the outside of our application. Not a class, we're writing them from the outside of our application. Because that's what's important. Nobody cares that your class has 4,000 tests and runs really, really fast. What they care about is whether the users are able to hit the APIs. That's what they care about. Nobody is going to praise you for doing 4,000 unit tests on a single class. So what we're talking about is working from the HTTP level. Now, I'm using this in the context of a service. Obviously, if you're writing libraries, the outside isn't your HTTP service area. If you're writing an internal library and in a source pattern, something like that, your external API surface is going to be the API. So that's the surface, not your internal factory classes, and not your factories of factories, and your factories that generate factories of factories. Those aren't the things that we're talking about here. We're talking about that external API surface. Oh, sorry, we're at a .NET conference, not a Java one. Okay. Cool. So it's also about testing inputs and outputs. What we're doing is we're testing our API from a perspective of the user. We're testing that we can get data in, we're testing that we can get data out. We're testing that we get data in and our response comes back right. Those are the things that are important. Those are the things that are important to users. So we're testing the inputs and outputs. We're not testing the bowels of our application because nobody cares. Nobody cares that you're hosting on Mongo versus SQL. Your user really doesn't care, unless they're doing a PCI audit, which they probably do. But we're also talking about testing from a user or consumer perspective. We're talking about the idea that an end user being, maybe it's you're writing an API platform, it's the people who are consuming your API. It might be that you're writing a library, it might be writing an internal service. The user is the person who's going to be hitting the thing that you build, not you as a developer. Obviously, you might be doing a multi-service architecture where you are your own consumer, and don't check your own homework, just get somebody else to do it. But the other thing is we're testing business requirements. Because we're testing at that consumer level, we're testing at that edge. What we're actually doing is we're testing from a business user saying, let's use the bank example. We're testing that we can do an authorization, and that authorization succeeds if we've got a good balance. That's a business requirement. I don't care that the balance class gets hit. I don't care that the transaction class gets a transaction added to it. I care that when I do my transaction, up at the top it succeeds. That's a business requirement. No business is going to tell you, make sure that your balance class returns true. If they do, then you've probably not got a business analyst. You've probably got a developer. So what do we get from doing testing in this way, in an outside-in pattern? Well, like I say, we're testing the business requirements first. We're not testing arbitrary things inside of our code base. We're testing what users actually use. We're testing what users actually want. That's the thing that we're testing. Now, the other thing is that if you're writing them from this way, you get the ability to write a lot more readability into your tests. So your tests become more understandable. You can use terminology that is terminology that you use as a business, not terminology that the transaction service class has been hit. Well, you don't really care. You're using business terminology, which makes things a lot more sense. Now, the other thing is each of your tests is holistically testing your application. You're not testing your class down here with your 4,000 tests that you're really proud of. We're testing the application. We're testing the thing that is going to be deployed. And this is where I come down to the building for production. We're building operable software now. We're building software that users care about and that operations can use, because they don't deploy your class with 4,000 tests. The other thing is we don't do any stubs or mocks. And I'm sorry if the creator of a mock is here, but I'm trying to get rid of you from every single organization I've ever been in. Now, the number one benefit for me is that we get 100% code coverage. Does everybody strive for that in their application? Do you have it in the build pipeline? Do code coverage tests? Doesn't get 100%, fail? How many of you have been writing tests and then realized that you can't test the dispose method? So that you add something in the dispose method so that you can test the dispose method so that you can get 100% code coverage. What you get with outside-in testing is the ability to say, well, if that code isn't hit, one of two things has happened. I've either got a missing use case, a missing test, that says, well, this is how the system works and that's why that code exists. Or you delete the code because it's never been hit. One of those two things is true, which means you can get to 100% code coverage. Not that 100% code coverage is a positive metric, it's more of a negative metric. The lack of code coverage will tell you that you haven't got enough tests. 100% code coverage does not tell you that you should stop testing. Do not stop testing at 100%. Okay. Now, what do we mean by readable tests? Now, when I talk about writing readable code, I talk about writing readable tests as well. We should put as much effort into our tests as we put into our actual code, because the tests are more important than the code. The code can be replaced. Your tests are what tell you whether your system works, whether it's functionally accurate. Those should live longer than your code should. We should also be refactoring our tests as well. Again, something that people miss when they're doing TDD. So the first thing is test names that are descriptive. Make your test name tell me what you're testing. What's the precondition? What is the thing you're testing? The amount of times where I see a test that says, does the thing. It's like, I call the class and it returns the correct response. Okay, but what's the correct response? Tell me what you're looking for. Are you looking for the right balance? Are you looking for the right name on the account? Are you looking for the right surname? Are you looking for the right first name? You've got a response on your API that's this big. You're not testing every single thing on there. What we're doing is we're giving ourselves signals so that when that thing failed, when that particular test fails, it tells us what it was testing. So we don't have to go delving into it and looking at assert messages and stuff like that to try and find out what it is. And God forbid, don't use equivalent to, please. Okay, reusable actions. So when we're writing readable tests, if you were writing your code and you decided that you were going to reuse a bit of code, you would extract that into a class, right? You would give it a nice name, some context, and then you'd reuse it over your things. The amount of people who don't do that in their tests is immense. We can do a lot of things with tests because they're code. If we're writing things in XUnit, if we're writing things in C#, we can use reusable actions. We can do extractions, and we can give them context, which makes our tests make more sense. We can use readable names for these things. We can also work on abstracting the implementation details. Now, if you're writing a test and the first line in your test is newing up the object that you're going to test, you're probably doing it wrong, because those things aren't important to the test that you're writing. The fact that it news up that object is noise. Abstract away any implementation details. Just make it make sense. And we'll go through some examples These are not all abstracts. I've got an example that we're going to walk through that will show you some of these techniques about how we do it. Now, the other thing is we're using domain language. Do not use the technical language. Use the language that your consumers are going to use when you're writing your tests. If it's to do with a authorization, so in the banking world, you've got authorizations and transactions. They're kind of one and the same. So if you've got one endpoint that says transaction, and sometimes it does authorizations and sometimes it does transactions, well, in your tests, use authorization and transaction as names. Give that context. Use that domain language rather than using the technical language. Well, I'm hitting the transaction endpoint, so I should just call it transaction because I understand what that means. Now, the other thing that I think a lot of people think is controversial is don't add 40 asserts in your test. Break that out into individual tests, and it comes back to that first point, which is make your test names descriptive. Yes, you can use the equivalent to, and it can massive object like this. But then what you have is a test that says returns correct response, which doesn't really give you that much information about why it went wrong. Have more tests. Don't shy away from having more tests. If you write reusable actions, if you write your tests in the right way, writing another test is copying 3 lines into a new test and then doing the assert and giving it a name. It's not onerous. These things run in nanoseconds most of the time. So adding more tests isn't going to make your test framework slower, but it does make it easier for you to understand, and it makes it easier for other people to understand. Because at the end of the day, we don't write code for ourselves. We write code for other people. How many people have come back to a code base and gone, oh my God, who wrote this? This is, oh, right, okay. So sometimes the other person is yourself. So be kind to yourself. So the other thing that comes up is, well, is what we're doing here not just BDD? Well, we're defining behaviors and we're testing behaviors. Well, guess what? TDD was about testing the behavior, not the implementation. That's what TDD was about. What we're not doing is we're not writing gherkin tests. There is no given when thens. We don't need that kind of complexity. We're writing the code ourselves. We're writing the tests for ourselves. So we can write them with proper C# code. We can write them with reusable test names. We can write them with reusable actions. We don't need to write it in a way that has given when then. But yes, we are testing the behavior. So yes, the original definition of what BDD was about, yes, this is what we're talking about. Cool, so let's have a look at some code as an example. Now, I'm going to be using here something called the Web Application Factory, which is a class in .NET that allows you to new up your entire API with all of the dependencies in memory. So there's no HTTP call going out over the network. It runs it all in memory. And I've wrote a little to-do app. There is a code sample. There'll be a link at the end that you can have a look at. Purposefully don't put it up so people don't go and look at it now, because then you'll see the answers. But what we're looking at is a to-do app. And it's not a bad test name that we've got there. So what we're going to do is we're going to add a to-do to the API and just make sure it returns OK. Now, people who are familiar with TDD write the most simple test first. Well, this is the most simple test. We've not even tested it, saved it anywhere. But we've made sure that it actually returns OK. It might have gone into the ether. I mean, obviously, the easiest implementation of that is returns OK in the method. Great. Let's do it. But the idea is we will write this first. It will fail because we don't have a to-do endpoint. But we can write tests like this in a TDD fashion. Write the test first. Describe what it is that your API should be doing. And then we'll write the test. Now, that test there will probably make sense to the majority of the room if you're all developers. And it'll make sense because it's like, what, 5 lines? 5 real lines? But we can do better. So we're going to use this really small example to show what we can do to make this small example really, really reusable and understandable in a wider context. So first thing we're going to do, remove the implementation. Now, if you look before, we had a web application factory. It does not matter for this test that I'm using a web application factory. That's an implementation detail. I don't care. When you look at that, it feels like that's important, to my test that I'm using a web application for? I'm not. It's not important. What's important is the other bits. So what we do is we're going to move that out. So in essence, what I've done there is I've just moved that into the constructor or into a base class. So it's not there. It's not important for my test. And already, this test is making a little bit more sense because I've extracted that out and I've called it API. So now what I've got is API.post. And I've got my add response. So API.post to the to-do, great. Makes a little bit more sense now because it's more succinct. But we can go a bit further. We can now work on a AAA pattern. I'm presuming majority of people have heard of AAA, arrange, act, assert. So, well, let's define what object we're trying to do because the object is important to us. Or is it? We'll find out. And then we do our action, and then we do our assert. Okay, so now we've got a pattern that makes more sense in people's head. But we can go even further. Now let's add some context. Because the values from that object aren't important. What's important for this test is that what we've got is a valid to do. We don't care that it's got those two properties. Those aren't really important to us. And this is called evident testing. Make sure your test only includes the things that are important to your test. Because when you come back to it and look at it and you go, is the title important? Is it important that it says new to do? Is that the only thing that's acceptable? Does it have to be that length? Is that important? No. What's important for this particular test, which is our with valid request, is that there is a valid to do. So I've given it some context and called it get valid to do and called it a to do item, a valid to do item, more specifically. Now the other thing is, well, we've got that test. Leave that test. That's good. It's a perfectly valid test that's going to say it'll return okay. I'm going to add another assert. Now, if you look at those first two lines are the same as the last test. So to create this new test, which this new test is going to do two asserts. Notice how I didn't say only write one assert per test. I said don't be afraid to write more tests. I'm not putting a number on it. It's not 5. It's not 10. It's not a specific number of asserts that's okay. It's about writing things for yourself later that allow you to be able to see what's happening. So what we're doing now is we're writing another test. And this one is going to specifically test that we've got a valid ID that's come back. Now, our return OK that we had before, it's not going to work anymore. So this will now fail. We're now in a test-driven development cycle. We're adding more and more tests that allow us to write the implementation detail. But at no point here have I reached into a database. At no point here have I injected some data. I don't care whether this is hosted on Mongo or SQL or Cosmos or any other system. I don't care. The user doesn't care, so the test shouldn't care. Those are implementation details. But we do want to check that things are persisted. So we want to check that when we've done our to-do item, because I can make that test pass pretty easy by just return 1 on an OK response. Great, test passed. I love adversarial TDD testing. It's amazing. When somebody writes a test and then you write the smallest implementation and you can troll them really bad. It's really funny. So what we're going to do now is we're going to work on our next test. And our next test is, well, we've created our to-do item. We need to make sure that we can get our to-do item back out. Well, we need an API call for that. One of my favorite things to do with BAs when they start to get into technical detail, when they go must save to the database as a acceptance criteria. Just say yes, it saves to the database and don't do it. Because until they've given you criteria that says I need to get it back out again, saving to the database doesn't matter. Because you can say, yeah, it's in the database and they can't check. Until they say to you, I need to be able to get that thing back out of the database on the GET request, you shouldn't even be thinking about how you store it. Because these things where we say need to go and get it, these are what are going to define those requirements. Too many times when people write TDD, they jump to the conclusion that they need a repository class and they need to test their repository class. You don't until you do, until somebody gives you that requirement. So this test here, what you can see now is I've actually abstracted all that stuff from the previous test. So those first 2 lines there, I've abstracted again into create valid to-do item. Because what do I care about in this test? Well, once I've added a to-do item, my range, I should be able to get that to-do item back, and it should have the right IDs. And again, what I've not done here is I've not gone into the database and injected and bleeded my schema out and the database implementation into my tests. What I've actually done is I've used my API to post that to-do item in and then gone and got it. Because too many times you have that one class with 4,000 tests on it that works really, really good, but doesn't integrate with anything else. So let's just have a look at what we've tested there in that particular scenario. Now this is a big one. We've tested our dependency injection startup. So how many people in the room have done a feature, wrote a really nice class, 4,000 tests, and then forgot to put it in your dependency injection container? Yeah, the people who are not saying yes, you are lying. Go away and think about your life. It happens. But you get it to production, and all of a sudden your application fails. Because, well, it's the dependency injection. It's not getting that class that it expects. With the approach of doing outside-in testing, it's already testing it. The other thing you're testing is routing. So you're testing the idea of, does my to-do item route work? Does it work with a slash or without a slash? Do they both work? Is that important? And guess what? I'd have 2 tests for that. One for with a slash and one for without. So we're also testing a really important thing, which is serialization and deserialization. Now, I always advocate when you're writing these tests to write your own models in your test. You know, everybody seems to love the .common class inside of their solution that stores all of their API models. And then they reference that in their class, in their tests. And then, well, when you refactor your common thing, well, your tests have been refactored as well. Oh, right, yeah, I've just broken all my APIs, sorry. What you're testing is serialization and deserialization, which means you actually get contract testing out of the box. Because if you've got to change your models inside of your test class, well, you know that your consumers have got to change their code. So now you've got to break and change. So you can actually alert on things like that. Somebody's changed stuff in the API models, so don't deploy. Let's have an extra approval step because somebody's changed the API models and we don't want to break our API. We're testing that serialization and deserialization. Anybody been caught out by the switch between Newtonsoft and system text JSON with serialization? Yeah. It works subtly different, and you don't notice it until you notice it, and that's normally too late. This tests all of those things because it doesn't care that you're using Newtonsoft. It doesn't care that you're using system text JSON. It cares that an object came in JSON, and then it just deserialized, persisted, and then when it came back out again, you got the right value out. We're also testing model validation. So we're not testing our little service class at the bottom here. We're not testing our little static helpers class. What we're testing is that whole thing. So if you put something on there that says must be a number, and it shouldn't have been a number, well, yes, we're going to test that. And guess what? There should be a test for it that shows those things. The other thing we're testing as well is database interaction. Now, in the example that if you go and look at the code for it, we're using Entity Framework. So all I did was I switched out Entity Framework for an in-memory SQLite database. So I'm actually testing all the database integration as well. I'm testing that my where clauses work because your service class won't test that. It'll test that you hit a mock. And obviously that's really good, yeah? But we're testing everything from selecting stuff to primary key constraints, foreign key constraints. All of those things are being tested holistically from the output. But like I say, we're also testing business requirements. We're testing what the business has asked for this API to do. And that is invaluable. Because the amount of times where the business comes up and said, oh, I didn't mean it to that, you can go back and say, well, it's not in the business requirements because I tested the business requirements. I didn't write an API on the abstract. I wrote it based on what you actually sent me, because here's all my tests that test all of the business requirements. So you're covering your own behind. But the other thing we're testing, because we're creating our own example client of our API, well, we're actually testing what the customer sees. So we're a customer of our API. We're a consumer immediately of what we're doing, which means that you're getting valuable feedback about how to use your API. When you're using that API and you're going, oh, this is awful. Oh, I wrote it. Okay. Maybe I shouldn't make it awful, because what you're doing is you're imposing on users something that you wouldn't use yourself. So I've told you all the awesome things. And if you look at that list, and I didn't show you anything else, everybody in the room is going, right, okay, this is something we should absolutely be doing. There's 0 downsides. Okay, but there are certain things that you can't test when you do this. So there are things like code path changes. Caching being a really big example of that. Well, I can test my API. If I need to test that it came from a cache or it came from the database lookup, I can't test that, because from the outside it looks the same, because it should look the same from the user. That to-do item that I go and get from the database, well, it looks the same whether it came from the database or whether it came from an intermediary cache or something like that. So from the outside, I shouldn't know. We also can't do things like auditing. So we can't test things like an audit trail was created. Or can we? We can't test performance. So we can't test the idea of how well does this thing perform in production. Because on a nanosecond scale that these sort of tests run, it's really hard to notice that things at scale will run. And at the end of the day, performance should only really be tested in production, because that's your only real environment that you've got anyway. Everything else is artificial. We also can't test cloud services in this model, because they're generally slower. So we can't test that it uses Cosmos. We can't test that DynamoDB is being hit. We can't test the configuration to make sure it's got the right config that points to the right Cosmos DB, the right DynamoDB, the right SQL database. We can't test that it's got security access either. However, some of those things we can. And this is where observability comes in. So let's talk a little bit about observability. So I said at the start that first and foremost, I'm an observability advocate. And the reason why I am is because I've built and run production systems for the past decade at varying levels of scale. And the idea of observability is really important to that, being able to know that your system is running in production and not relying on hopes and dreams, because they don't work. So let's define what observability is. So Charity Majors, our co-founder at Honeycomb, coined the term 2016 in the context of software, which is the idea that it's about understanding and debugging the unknown unknowns, and it's about understanding the the inner system state by asking questions from the outside. Now, if you look into that, you can actually see why I think this is important to what we're talking about with outside-in testing, because it's the ability to understand our inner state. Well, that's what we were just talking about, the things that we can't tell, the internal bits of our application that we can't know about. Well, actually, yes, we can, because observability is about that idea of knowing those internal states. So let's talk a little bit about observability-driven development, observability during development, whatever you want to call it. There is no accepted term, and I really don't want to coin a term. But what we're talking about is using observability during our development lifecycle. Whether that's local development when you're doing it and running it up locally, or whether it's inside your tests, it's the idea that observability isn't just for production. You can also use that locally. Now, the first thing is, observability is an output of your application. We talked about testing inputs and outputs of our application. Well, observability is an output. It is something that our system tells us about our system that we can use. There are certain things that observability can do. It can detect parallelization. You can test that two things run at once. Anybody swear blind in their application that two things ran in parallel, and until you actually saw a waterfall chart, and then realized, oh no, they run in series, don't they? Yeah, that'd be why the system's slow. I've done that numerous times, and the amount of times where we go into organizations, put tracing into their application, show them that system, and they go, yeah, that all runs in parallel, and then you go show them the waterfall chart, and it doesn't. It's like, it starts when this one finishes, and they're like, no, it's wrong. It's not wrong. The system's telling you that it's doing that. But observability can detect those things, and that's really important. It can also detect which code paths. Because if you write tracing into your application, if you do manual instrumentation, you can detect which kinds of code paths have been taken through your application. Now, the other thing is that what's important in your local environment is likely important in production. Now, if we take the caching example, where we care that a second request hits the cache, that's important to us. Well, that's important in production as well. I should care in production that things are hitting the cache when they should hit the cache. So all of a sudden, this is an output that we need to have in our application. So let's look at a little bit of code. Now, what I wanted to prefix this with is doing this approach is not a way around you injecting things into the database and reaching back around and just add some things in just so that you can test them. Please don't do that. But what it is the ability for us to know our application a little bit better. So this is a bit of caching code. For any future employers out there that might be looking at me, this is not how I would write a caching code. This is an example, and it illustrates what I'm trying to talk about. So for those who don't read code fast, what we're doing is we're creating a to-do list. We're putting that in a memory cache, and then we're going to go and get the to-dos from the database, put them in the memory cache. Next time round, we're going to go and get them from the memory cache. So pretty simple implementation. The idea is first request goes and gets it from the database. Second request will always get it from the cache. Forever. Don't write caching code like this. If anybody comes up and says, Martin said I wrote this and then I got fired, disclaimer. Okay. So if we want to write a test that says, did we call the database or did we call the cache? Because we want to assert that, well, the first call hits the database. Notice the test name. Test name's really specific there about what exactly we're trying to do. Tells you exactly what we're trying to achieve. So what we're going to do is we're going to use something called OpenTelemetry. OpenTelemetry is the #2 project on the CNCF Foundation. It is the de facto standard around tracing and becoming the de facto standard around metrics and logs as well. And what it provides us with in this particular context is the ability to have a tracing provider. Now, there's a lot of code there, which we'll walk through a little bit. But what we're doing is inside of our test framework, we're going to set up a tracing provider. We're going to monitor some specific traces or tracers. In .NET, that's called activity or activity sources. We're going to monitor some of those. We're going to add something called a test span processor, which is going to allow us to say which test run this was part of. And then we're going to add some auto instrumentations. We're going to add in the ASP.NET Core instrumentation, which will automatically do some tracing for us. But we're also going to add in something called the in-memory span processor or in-memory exporter. Now, what that's going to do is it's going to say that every span that's created in our application is going to stick it in a dictionary for us. It's actually a list. But it's going to stick it in there for us so that we can interrogate it. So we can know for an individual test what spans were created. We're also going to add Honeycomb in because I work for Honeycomb, so I'm obviously going to add Honeycomb in there. Okay. So the other thing you need to do is once you've got your tracer, you then need to use configure services. So if you're using the Web Application Factory, you have access to inject more services. So yes, the stuff that you've defined in your program and startup.cs, whatever you're using, those are still there. But you also have a hook to add more services in. So we're going to add in the tracer provider. Now, there's a lot of people who are reluctant to bring in something like OpenTelemetry into their application because, well, that's an adoption thing. That's everybody needs to use it. What we're using here, though, is OpenTelemetry in the context of tests. There's not a wider adoption here. We're not talking about adopting OpenTelemetry as a standard across all your applications, all 4,000 applications that you've got, all your services, using distributed tracing. We're not talking about all those. Yes, you should do those. Come see us at the booth afterwards and we'll show you how. But what we're talking about here is using it for tests. We're using it for observability inside of our tests so that we know how our application is working, so that we can stay on the outside and build our tests from the outside. So we're going to add in the tracer provider, clearing the logging providers because on Linux it doesn't like it a lot of the time, but hey-ho. So now what we can do, that caching code that we talked about before, what I've done is I've wrapped it in a using statement. I've created an activity called getToDoList from DB, and I've wrapped the bit where it goes to the database in that span. Now, the reason I've done that is because that's something I would probably want to report on in production. In production, I'd want to know how many times did it go to the database versus how many times did it not go to the database. So we've got a span created now for every one of our calls that comes in only when it hits the database. So now we can write a test. So now we can write a test that comes in and says, right, go and do the GET request. So API get to do list. Great. Also, don't call your endpoints to do -list. It was just easier. So we're doing a get for our to-do list. And then what we're going to do is we're going to check our spans on the back of that and say, did one of them contain this? Yes. Okay. Well, we're going to make sure that that wasn't null. Now what I've done is I've wrote a test that tells me if I make one GET request, it's always going to go to the database. Great. I don't need to go and check a mock. I don't need to go and inject into my application something that I can use a mock verify to see whether it hit it. I don't need to do any of that. I'm stayed on the outside, and I've got a really succinct test. Now, I've kept that, and I'm not going to refactor away that bottom bit where it does the cache activity, but I would obviously go and then refactor that to put some reusable action and give that context to say span exists or something like that, that makes it readable for you to use. But now what we can do is we can write the next test. So first one, same as we did before, get the to-do list, clear out any spans from that call because we don't care about those anymore. Make the second one and just make sure we don't get it. Make sure there isn't a call, there isn't a span created that has the to-do list from the DB. So I've been able to stand on the outside of my application completely. And now I've been able to test some of those internals. But what I've also done is I've made sure now when I go to production, I've got some observability around when cache hits happen, because if it's important to me locally to know that that code path was taken, at some point it's going to be important in production. So if you get those in your test and you keep writing the test in this way, you are going to be able to get better observability in production. And this is why I talk about building operable software, because you're considering what it would take to get to production. You're considering what production would look like. You're not writing it for local, because let's be honest, if you wanted to do that locally, yes, you could write some mocks in your controller classes, inject all of your stuff in, make sure it goes to the different places, or just hit play and then debug it through. Yes, it works because I debugged it. Now, the other benefit that you get from this is you can then go and look at these results in your observability backend. Obviously, on this one, we're showing Honeycomb. So each one of our test runs now becomes a trace that we can then look at. Not that impressive when you look at it in a graph like that. But if it's a trace waterfall, I can actually look for each one of my tests that's run, each one of the traces that's been created. I can follow through how that hit my code. I can work out, well, was that slower or faster than the last time? And yes, we are talking millisecond, nanosecond scale. But it will show you. And you'll be able to say, actually, no, this went through a different code path this time. The test failed. Okay, well, it went through a different code path than it went through last time. It kept it in the database. Oh, maybe the caching's not working. So it gives you more things to look at. And you can look at things like how long did my test run go, which ones were the slow tests. With the advent of stuff like GitHub Actions, we're losing a lot of the things that we used to have that were built into CI/CD runners. but this allows you to do that. But it also allows you to say, this is what it looks like or should look like in development, in my tests. When I go to production, does it look like that? Because that request should look identical, because the trace should look identical. If you've got a test in place, that trace should look identical. That is all I've got to show you. I wanted to give you a few different jumping off points from here. So there is a repository that you can go and look at. There's a few things that I also think would be really useful for you to go and watch after this. So Ian Cooper, who is on in the other room, thanks for coming to see me, not him, by the way. A lot of the things that I talk about here come from the TDD Revisited talk that he did at NDC London a few years ago. And it's a really, really good talk that breaks down what TDD is in a much, much more depth way than what I've talked about today. The other one is a guy called David Whitney, who wrote a talk called Writing Tests That Don't Suck. And he did that at NDC London as well. Go and view that. That is a really good talk. It goes a lot more into depth about readable tests and writing tests that are better, not specifically about outside in, more about just writing readable tests that are really, really good. Obviously, I work for Honeycomb, wouldn't be here without them, so you can have a free account forever with us. Come see us on the booth if you want to chat about it. And we also wrote the book on observability engineering quite literally, and it is free for download if you go and get it on our website. And that's me. Thank you very much. I have a little bit of time for questions if people want to ask stuff, but if not, just come up and chat.